Hello, the task here is to prove this, or to find all solutions for which the cosine of 2t equals t. And as was suggested on the previous slide, there were 4 solutions, but there's only 3 solutions to this equation if you limit it to 0 to 2 pi. Turns out that fourth solution is exactly 2 pi, and if you don't include 2 pi, then it would only have 3 solutions. So to go about this, we're going to start using the trig identity for the cosine of 2t, which is 2 cosine squared of t minus 1 is equivalent to that cosine of the double angle is equal to the cosine of t. So this is very similar to a previous section where you've seen how we can use everything we know about quadratics and factoring in the quadratic formula in order to solve. So I'm going to start here by just cleaning this up a little bit, doing a subtraction of cosine of t from both sides of the equation. And what that's going to give me is a pretty clean quadratic, 2 cosine squared of t minus my apologies, the cosine of t minus 1 equals 0. And I'm going to jump in and I'm going to substitute right here. I'm going to set the cosine of t as equivalent to x, which would actually just make this 2x squared minus x minus 1 equals 0. And this factors to be 2x and x. In order to create that negative x, we'd have to have the 2x become a negative 2x, and the 1 over here would be the positive, such that we have 2x squared minus 2x plus x gives us that minus x in the center, and then minus 1. That works out. Looking at those two solutions, we have either 2x plus 1 equals 0, or we also have x minus 1 equals 0. So the solutions are x equals 1, or x equals minus a half. If we subtracted 1 and divided by 2, that's what we'd get. This is where I'm going to kind of bring back the cosine into it, that those are the solutions for x. But instead, I'm going to call this the cosine of t is a half, negative a half, or the cosine of t is 1. Well, looking over here, thinking about where the cosine of t would be minus a half, well, that minus and a half would look right like there. It would look something like this, where this would be 1, this would be minus a half, and that corresponds with a angle of, I think of it as 1/6, 2/6, 3/6. You could think of that as 4 pi over 6, or 2 pi over 3 would be the simplified form. And going on to this other triangle that would fit the same thing. If you think continue with a 6, 5/6, 6/6, 7/6, 8/6 would be the other angle, 8 pi over 6, or 4 pi over 3. So those are the two options for here, for what two angles could produce that. So those are two of the solutions. And then if we look at this other, the cosine of an angle equals 1, well, that only happens right at the very start when the x value is positive 1, and that doesn't happen again until you do a full circle. So the last slide suggests there would be 4 solutions to this. Saying 0 and 2 pi would be another 2 solutions, but it also limits the domain to not include 2 pi itself. So I'd argue there's actually 3 solutions to this scenario. 2 pi over 3, 4 pi over 3, and 0 would be your final answers.